My name is Andrew Russell. I'm here from Wargaming Sydney, and today I'm going to be talking to you about a personal philosophy of excellent engineering. And I'm thrilled to see everyone has come to see this today. This is my first time speaking at GCAP, and yeah, that's excellent. Thank you. This talk is going to discuss three ideas that I've had in my head bouncing around for the last decade or so that I've been in the game industry, first as a freelancer and more recently at Wargaming. And these three ideas are hopefully for some of the more senior developers in the audience, they're going to seem like things you hopefully already do. And so for you, my hope is that these three ideas, you can take them and put them into your matrix of ideas that you have on how to do, hopefully, excellent engineering. But for the more junior developers in the audience, this talk is actually aimed at you. One of the things that separates junior developers from senior developers is the ability to quickly make good decisions. In the industry, we call this being a seasoned developer or having good taste. And essentially what this boils down to is being able to make those quick judgments that allow you to make good decisions. And part of the hope of this talk is that it will give you a few ideas that you can use as perhaps shortcuts to increase the speed of this process for yourselves. One of the things we want to do in the Australian game industry is we want to develop our more junior talent to being more senior, and the hope is that this talk will form a little bit of an accelerating factor in that regard. And so my hope is that for you, those three ideas that I'm going to talk to you about today, you'll be able to use those ideas as kind of seeds, and you'll grow out your own, again, hopefully excellent, personal philosophy of excellent engineering. So, what do I mean by philosophy? I mean a system for making value judgments. So, being able to say, this thing is better than that thing. This is more important than that thing. I should spend more time focusing on this and less time focusing on that. That is the kind of taste that I'm talking about, that sense of making good decisions. So I've talked about the first part of this title, personal philosophy. Our philosophies of engineering do tend to be fairly personal. The second part of this title is excellent engineering, and I chose that on purpose. First of all, excellent. I didn't say good engineering or great engineering. I said excellent engineering. And I also wanted to get that double alliteration, personal philosophy, excellent engineering. Thank you. As something that, it's not required semantically in the title, but it is something that's interesting to the humans who are listening to it. So I'm, flattered that everyone's come here to listen to me talk today. And so hopefully that's worked. So let's start with the first idea. And the first idea comes in the form, appropriately enough, of an aphorism. An aphorism is a short phrase or saying that, when spoken and thought about, expands out into, again, a greater field of ideas. So the first idea that I'd like to share with you today is this. Programming languages are a method for communicating with humans first and machines a very distant second. Again, programming languages are a mechanism for communicating with humans first and machines a very distant second. So when we're programming, first and foremost, we're communicating with ourselves. We don't sit down in front of the computer, hopefully, and flick switches to change binary values. We don't generally program in hexadecimal, and very rarely do we actually program in assembly. We go up level after level and program in higher level languages. And you might say, what about register assignment? And yes, that's true, but that's, again, very distant second. The most important part is it allows us to think in more human terms. We're also obviously communicating with our team. When we check in code, there will be other people in our teams who will be reading that code. We're also communicating across teams. So, for example, at Wargaming Sydney, I am working on netcode for what is essentially middleware, internal middleware. And so other teams will be reading the APIs that I produce. And when they have a problem and I need to support them, I go and actually read their code as well. And so it's very important that our code communicates with a human on the other end of that discussion. And that's just the immediate needs for communication. There is a more important one, and that is communicating across time. Something that you've hopefully all heard before is the cost of maintenance for software is approaching an order of magnitude more than the cost of producing that software initially. So it depends what study you look at, but somewhere between the high 80s to 90% of the cost of software is in maintenance, which means that anything that you write today, anything you do to make that more readable, is going to make that software easier to maintain and cheaper to maintain in the future. Again, I work at Wargaming Sydney, and you might have heard of a small product called World of Tanks. That game is about 12 years old at this point. And so occasionally I find myself touching code that is more than a decade old. And what that means is I can't just pick up the phone or send off an email or send off a Slack message and say, hey, what did you mean when you wrote this? So it's very important that our code communicates directly. And so let's talk about what it means to write code for humans. First thing we might want to do is consider our audience. What do they bring to the table? We can probably assume that they know how to program. I think we can take that as a given. Generally speaking, we'll have some sort of domain knowledge involved in the code. We need to think about how much of that domain knowledge they're coming into the code with and what sort of external documentation we can provide, or links or whatever, that hopefully survive on the internet, in order to fill them in on that domain knowledge. We can also consider, say, what language they speak. Generally, when you're programming, the default is US English. Sorry to everyone who spells color with a U. But your audience may actually speak Japanese or something like that. One neat idea, if you have an English-speaking audience, is you can do small, subtle things in your code to better communicate with that audience. So, for example, if you're writing a conditional or some arithmetic statement, sit and read that out aloud. Does it form a sensible English sentence? If not, then maybe you can reorder it to make it make more sense. And it's these small little changes that communicate better with, again, humans. They're not important to the computer, but they're important to the humans that will be reading it. However, another way you can do this is if you are writing some mathematical piece of code. There are conventions in mathematics that exist for reasons. So I'll give you an example. I write a lot of code involving ranges of numbers and comparing ranges. And when you specify a range in mathematics, one way of doing it is to have lower bound is less than the variable is less than the upper bound. You can write your conditions this way, and if you do this pervasively through some code, it suddenly becomes more readable and more understandable if you're consistent about this. So there are some ideas, and that should start to give you a sense of the little things you can do to improve the readability of the code that you are writing. So we are writing for humans. What else can we do to improve this? We can look at other fields that are writing things for people to read, literature, novelists, journalists, that sort of thing, and think about their techniques and maybe steal a few. So one thing that you find that, say, people writing prose will do is they will take the thing that they've written and they will change the font, they will change the page width, and they will view it in different ways to come at the thing that they have written fresh, because that's what the audience will be doing. And usually you find mistakes when you do this. So if I'm writing a piece of code, I'll give you another example, but again, this is my personal philosophy. You might have a different way of doing this, but it's the idea that's important. So I'll read it once in the IDE, top to bottom, and then I will read it in my diffing tool before I commit it to the source control system. And finally, I will read it a third time in the code review system. So I've read it 3 different times, and sometimes people get a code review from me, and I send them the link, and it's like, that's revision 2. I'm like, yeah, I found a problem. So that's another important technique. Proofread your work. This, of course, implies the next step, which is, of course, editing. This is the equivalent to code reviews. Hopefully, you're all doing code reviews. They're very important. And this is one way you can get a fresh set of eyes on your code. When I'm doing code review, and when hopefully my team is doing a code review, obviously we find bugs and problems in the code, but the number one thing that I am looking for is readability. Have you written something that is as readable as possible? One important thing about this is it's very difficult to get readability onto the schedule. Hey, this code could be spruced up a bit. It's not as well readable as possible. So the right time to deal with readability issues is in the code review. It's really the last opportunity. Otherwise, people will move on and be like, hey, we need more features, we need to do stuff now. Slow down, because again, in the moment, it doesn't seem that important, but cost of maintenance across a long span of time, you will actually make that value back. So obviously, if we're doing code reviews, this implies that we're going to be reading a lot of code, and there's lots of techniques for reading code. I read top to bottom, and then I'll do another pass. I'll go through the functions, and then I'll do another pass, and I'll go through the data. So I end up with something that looks like a call stack just written by hand, and then I usually have I make notes on which data is changed by which functions, which change the state of the system. And usually by that point, I've read it 3 times, and I have a good understanding of that system. However, there are other techniques to reading code. Other people do it bottom to top, which is an interesting one and a useful one if you want to come to a piece of code fresh. Read it bottom to top. Some authors read backwards. I have a colleague. They like to explore code by doing a full text search on important keywords related to the thing they're trying to learn. So one thing you can do, I'll give you a exercise that you can do at home, and that is read a whole bunch of code. Read some big, meaty chunk of code. There are open source engines out there. If you are an Unreal licensee, hey, the Unreal Engine source code is actually really interesting to look at. Go and read and learn about a chunk of code that you can find. And then while you're doing that, make notes on the things you find easy and the things you find difficult, because then you can take those ideas and put them into your own writing of code to hopefully make your code easier to read. I'll give you another exercise, and this is a really good exercise for writing understandable code. It's a bit of a challenge. So what I'm going to do is I'm going to challenge you, please try and write a complicated piece of software, a modestly complicated piece of software, hopefully fairly standalone, not too many libraries. When I did this myself, I wrote a heap allocator, so about that scale. And the challenge is this: write this piece of code so that other people can read it, so it's understandable, without using any comments in your code. And what this will do is this will force you to think very carefully about all of your variable names, about the layout of the code in the file, how you group different things. When you introduce topics, if you were reading this file top to bottom, you will need to use all of these communication tools to write code that is understandable if you don't have comments to lean on. Now, another nice feature of this is if you are finding yourself doing this exercise thinking, man, I really need a comment here. If I could just use a comment, I could explain this thing really succinctly and easily. That will give you a hint. Those are the comments that are important. Please write lots of those comments in your code. It will also tell you, hey, I was able to change this variable name around and avoid adding a comment into this particular piece of code. And so now in the future, you won't need to write those little comments, which means that suddenly the number of comments in your code is reduced and the focus goes on to those most important comments that are describing the why you are doing something, what is important about this line of code. Those are the interesting ones that you want to keep in your code. I mentioned grouping things by lines and ordering things in the page. I want you to consider the extreme of this. I've talked about writing prose. You could go as far as to think of the code on the page as ASCII art. You could care very deeply about the positioning of every single character on that page. I don't suggest that you actually do that, because that would take a lot of time, but I want you to understand that that is sort of the limit of where you could be. The sky's the limit sort of situation. Now, I've spoken about a number of things that are potentially talking about things that could be coding standards. They might be violations of some coding standards you have. And whenever I talk about coding standards, there's always a little bit of pushback. And what I want to put to you is that coding standards tend to form local maxima. And this means two things. Number one, I might think my coding standard is really good, and you might think your coding standard is really good. And for each of us, it might be a global maximum, because my standard works for my situation, my team, my culture, my business needs, and yours might work for yours. And so if we're both having that discussion, we both are saying, you know, the grass is greener over here. There's also the fact that, again, they're local maxima, which means that if you want to change a coding standard, you have to sort of come down off your local maxima and try and go up another one and hope that it is actually better than where you were before. So things to think about in terms of coding standards is think about how rigid you need them to be. So if you have developers who are writing code somewhat chaotically and willy-nilly, then you probably do actually want a rigid coding standard that enforces a lot of things. If you have developers who care deeply about, say, the readability of the code, you can actually loosen up on those coding standards, because they will do things that are not nicely neat and ordered, but they will do them for a reason. And this is the sort of thing you should be looking for again in code reviews. They've put extra line spacing between these methods. Have they done that just at random, or have they done that for a reason? So let's talk about line spacing a little bit more. One interesting fact about white space, actually. Horizontal white space. A large source of bugs, I believe it's in the top 10, is if you have methods that are one after the other. So they're kind of copy-pasted and they work on different variables. Say you're working on the width of something, 5 characters, and the height of something, 6 characters. Then if you have a long line of statements or arguments to a method that have different character lengths, you end up with different line ending positions. If you add some extra spaces to make them all into columns and form a tabular layout, this actually reduces the instances of that kind of copy-paste bug where, hey, oh, we forgot to actually change one of these when we copy-pasted it, for example. And it's not that we found that through the computer. Very distant second, again, it's because a human was able to read that more easily. So again, I would encourage you to think very carefully up to the point of thinking about where every single character is on the page. And so if you have, again, coding standards that are very rigid and say you must have this many spaces in this many places, it means that you are effectively deleting that human readable information. If there's an inconsistency, the eye is drawn to that inconsistency and you can use that effect on purpose. And so if you have a file, for example, that is very rigid and organized, that will indicate to the reader, hey, someone has spent a lot of time focusing and thinking about this piece of code. Whereas if there's a little bit in the middle that is actually a little bit inconsistent, it says, hey, maybe someone went through and patched that at a later point. And if the file is kind of a patchwork, then perhaps it means you need to go through and think about that whole file as a single unit and think about all of the interrelations in that file. And the layout, the subtle hints in that code will give you hints towards that. But if you're, say, running an auto formatter across your code, you're getting the rigid organized version of the code by cheating. You haven't actually made it well thought through. It just looks that way. So remember that you're communicating first and foremost with a human. So, if we're going to be communicating something with a human, we, first of all, should hopefully understand that thing, which brings me to the second idea that I want to share with you today. And it comes in the form of a recipe, a series of steps. Step number one is understand the thing that you want to communicate. Understand something that is true about the universe, something that is true about reality, something that is true about the problem domain. Step two is communicate that thing. That communication could come in the form of Slack messages, emails, documentation, and obviously code, as we've been talking about. Step number three is that maybe at some point we want to compile an executable and sell it to a customer. But what I find is that step three is actually not the important step. If you are doing a good job of steps 1 and 2, step 3 will largely take care of itself. So I want to give you a counterexample. What happens if you try to understand something that's fictitious? If you are spending a lot of time trying to understand someone's object hierarchy, then what you are understanding is something that someone has made up. It's not something about reality, it's someone's interpretation of reality. And hopefully at this point, we all have a rough understanding that things like object-oriented programming didn't really live up to the hype from the 90s. The hype in the 90s is that we would be selling and distributing objects rather than software, and that never really materialized. So let me give you an example of something that is true that you could understand. Physically based rendering. If you've been watching the industry over the last 10 or so years in terms of physically based rendering and how much everyone understands about how light moves around surfaces and propagates and so on, then you'll have noticed that, hey, our rendering technology has gotten a lot better and is more accurate. It tends to be faster, it tends to be easier for the artists to manage, and that is because we understand that topic really well, and that is something that is true about the universe. So we then get on to step 2, and we talked about communication, and you might understand that this forms a cycle. And you might have heard about this before, and that is one of the most effective ways to learn something is to teach it. And so this is what you're doing by communicating. When you go to teach someone something, you will very quickly identify where the holes are in your knowledge. So for example, when I'm trying to learn a particular topic in detail, I will usually go and make a PowerPoint presentation that I can then later present to my team. And obviously one of the benefits is that I can give this presentation to my team and say, hey, here's some things that I've learned that I can then pass on to you. But the number one reason is that it helps me identify gaps in my knowledge and fill them so that I understand that topic in totality. Another technique you might have heard of is rubber ducking, which is where you get a rubber duck and you explain your problem to the duck. And when you're explaining it, the reason this works is you'll realize, hey, that's the part I don't understand, and then you can go off and explain it. You might also use a colleague for that. So if you have a good understanding of what you're trying to communicate, you will tend to write better code. You'll have a sort of a solid core of your code that you understand at a deep level. You'll also have an understanding of where the edges of that understood deep area is. You'll know where the rough edges are, and then you'll be able to do things like writing comments into your code. Hey, this is a bit we haven't really considered in any detail. Or you can put in assertions that say, hey, you're going down a path that we haven't really thought about, so hey, we're going to blow up and make that obvious. So what it means is you have this, because you've understood it well, generally fairly bug-free core, and generally sort of, I'd say, explodey sort of rough edge that will tend to be bug-free. And this will help with things like intuitive debugging. If someone sends you a video of, hey, this is your code misbehaving, you'll be able to say, oh, it's in this line here. And so that's very important. It also will direct, because you can do that, it will direct where you need to focus your testing efforts. So I've talked about a iteration between understanding and communication. And I want to introduce this idea that there is actually a spectrum between people who understand and communicate kind of slowly and people who iterate very quickly. I, for example, am one of these people who will go off and will sit and think really hard to understand a particular topic, and then I will go and program. However, I can't say that that's better, because I know that there are lots of developers out there who have incredibly tight iteration loops. They will sit in the compiler building things and building up their understanding through essentially interrogating the software in a sort of scientific way. And I've seen both of those methods produce excellent results. So it helps to think about where you are on that spectrum, and it helps to understand what the flaws are in your iteration time. If you are a slow iterator, one of the problems is you can sit there and think for a really long time and then go to program and, oh, I don't understand this thing at all, which is a huge problem. And so you need to be aware that you might end up in a situation where you spend a week thinking and haven't produced anything, and it looks like you haven't done any work, which can be a little bit embarrassing. So make sure you build in enough time to actually go back and fix your understanding if that's going to be a problem. Think about your schedules. On the other hand, if you're a fast iterator, you can actually get into the same situation. You're iterating quickly, and then you suddenly realize, oh, I haven't understood this thing I've written. But now you're in an even worse situation, because you've written a whole lot of code that probably compiles that someone might want to ship. And that's a dilemma. And there's a serious question there is, do you wipe that away or do you ship it? And that's a question we'll talk about in a moment. So if you find yourself in this situation, if you understand which mode of iteration you generally fall into, try and understand what the flaws are in that mode of iteration. And so if you're a slow iterator and the understanding is not quite working out for you, force yourself to write something into the computer to try and understand it in that way. If you're a fast iterator and you're just writing a lot of code that's not really making sense, pull yourself away. Sit on a couch with a piece of paper and try and figure out what your problem is. And you'll generally break through that sort of understanding barrier by doing this. One other flaw in the fast iteration mode that I want to talk about is when you forget the understanding step. And this is the case where you're just writing random code and sort of throwing it at the compiler to see if it produces the result you want. You're not actually understanding what you're writing. You're just sort of doing a kind of random search. And this is obviously not a good situation to be in, because you don't get all of those benefits of understanding the code that you've written. And if you actually do produce the result you want, it probably means that it is difficult to understand because you haven't understood it, you haven't communicated it well. It's probably buggy in subtle ways, again, that you don't understand very well. So try, if you find yourself in that kind of random search mode, again, pull yourself away, sit on a couch with a piece of paper and figure out your problem there. Now, as somewhat maybe as an advanced technique, is occasionally I will go into that mode deliberately. And the important thing is I always acknowledge when I'm doing that, and I acknowledge that the thing that I'm trying to understand is actually not that important, and this time saving is more important. So I usually do this in very small sections. For example, it's like, I've worked out this algorithm, it's all good, and there's an offset. Is it plus that offset or is it minus that offset? Oh, I don't really care at the moment. It's not important. I'll try plus. No, it's minus. Okay, it's minus. Ship it. So really tiny sections, I might do that on purpose, but I'll always acknowledge that I'm doing that, and I'll do it deliberately. And there is a kind of meta point here, and that is you can understand your own psychology and manipulate it. And there's lots of techniques around this area. If you've looked at literature on, for example, time management, that talks a lot about how you can think about your own psychology. So I'd recommend that you spend some time looking into that. Obviously, we don't necessarily have time to talk about that today, but it's a good field to be aware of. Speaking of awareness, this brings me to the third and final idea that I want to talk to you about today. And that is something that I call the awareness stack. And it's a kind of metaphor. So I'm aware that there's probably a few programmers in the audience, so I need to clarify that I'm not talking about a computer science stack. We're not pushing and popping things. We are talking about a literal stack, except it's a metaphor, so it's a figurative stack. And essentially, it's made up of concepts that are vaguely ordered and sort of areas of ideas. And we're sitting in the middle. We are understanding something and then communicating that understanding and writing some code. And we can navigate this stack by asking questions like why. We can go up the stack. Why is this thing this way? And we can go down the stack by asking questions like what? What is this thing doing? So I'll give you an example. We're writing some code. Well, what happens when we compile that code? The compiler will compile that code and write it into an executable image onto the disk. Then what happens? We want to run that code. We're going down the stack. The operating system is going to load that executable image into memory. Then what happens? The operating system sets the instruction pointer to the start of that memory. We're going down further. Then the CPU fetches the instruction from that point in memory, and it loads it into the front end, which decodes that particular instruction, and then that sends it into the back end, into the scheduler, and we're going down and down and down, and that scheduler puts it into some execution ports, and in those execution ports are, ALUs and so on, and then those ALUs are made up of logic circuits, which are made up of gates, and then sort of you get down to the bottom, it's like, how do you dope silicon? And you find yourself asking questions like, electromagnetism, how does that work? And so then we can navigate upwards. Why are these gates turning on and off? It's so we can add some numbers together. Why are we adding some numbers together? Because that's what the instruction was. Why is that instruction adding numbers together? Because we told the compiler to do it when we wrote some code. Why did we write that code? We were trying to understand it. Why did we try to understand it? Because our manager asked us to. Why did our manager ask us to? Because we need that particular feature to implement some feature that we've promised another team. Why did that other team ask for that feature? Because they need it for their own feature. Why did they need that feature? Because they are making a particular game. Why are they making that game? Because the marketing department said, hey, there's a gap in that market that we can sell this game to. And why is that? Because we surveyed some players, and there are some players out there who want to play our game. And why do we care about that? Because they're going to give us some money for that game. And why do we care about that? Because our company would like to make money. And why do we care about that? Because if our company makes money, then we get paid. And why do we want to get paid? Because we can like to buy some nice things. Or, if you don't like that sort of capitalistic metaphor, we can look at the other side of that transaction. There is a whole bunch of players out there in the marketplace who would like to play the kind of games that we're making. And so why do we want to make a game for them? Because our company exists to make games that people like to play. And why do we want to work for that company? It's because, we would like to express ourselves in a kind of quasi-artistic kind of way that other people will enjoy. And then you get to the very top of this awareness stack and you're asking questions like, what is the meaning of life? All right, problem solved. Okay, thank you very So the reason I bring up the awareness stack is because the awareness stack represents reality. This is the reality that your software, that your communication and your understanding is being tested against. And so obviously you need to have at least an awareness of what is in this stack at hopefully all levels. Obviously you don't need your attention constantly, that would be impossible, but you at least need that awareness. So if you're, for example, writing a line of code, there are different ways you could write this line of code. There are small micro decisions you could make. And so if you understand sort of the lower levels of the stack, you might know that, hey, if I write this in this particular way, the CPU can run these two instructions in parallel and it will run a little bit faster. Or, hey, it's going to fetch memory in this particular way, and I know that that's going to be in the cache, and so that will run a little bit faster that way. So you can essentially do kind of small optimizations like this that will make your code a little bit faster. Or if you understand up on the stack, you might understand the business needs. For example, there are different ways you could write a piece of code. Is it important that you write it in such a way that it's very narrowly focused now? Or is there a business need that, hey, we might need to expand on this later, so we should leave in some places for extensibility within this code? Or both. It could be the case that, hey, I could spend a little bit of time trying to figure out a fast way of doing this. How important is it to the business that this particular line of code is fast or not? And so we need to understand both what the options are for optimization and what the options are in terms of what the business actually needs. And so, for example, earlier I talked about, hey, we've written a whole lot of code and it's really bad. Do we ship it or not? This is a question that you can start to come up with answers to by thinking about the upper ends of the awareness stack. For example, you probably have a manager that you can have this conversation with, but having that awareness will say, hey, here are the people that I need to talk about making a good decision here. And it will give you an awareness of what their concerns are and what language you should use to communicate to them about making that decision. And they probably have their own awareness stack as well. And they need to actually be able to, they need to have an awareness down to the engineering level to understand what the engineering concerns are around that. And so in that way, you can both communicate together. So I'll finish off with an example. Say you're trying to optimize a line of code. So you could write that code differently in different ways, and that means that the compiler is going to emit different instructions. And then if it emits those instructions, it means it's going to decode in a different way, which means it will feed into the schedule in a particular way, which might allow it to assign to parallel execution ports, which might mean it runs a little faster, which means that at the very bottom, because it's finished earlier, it allows the CPU to turn off some transistors and save a little bit of energy. And if we go up the stack, we say, hey, why are we trying to optimize this piece of code? Well, our manager asked us to optimize it because the company is spending a lot of money on servers, and if we make the servers run quicker, we can save a little bit of electricity in our server farms. And then, at the very top, we can be like, well, we probably want to spend a little bit less carbon in the world running these servers. And so, in my experience, the best engineers are those who are able to stretch their awareness moment to moment across the entire range of that awareness stack. And as they're able to do it, they are able to understand things better. And when they understand things better, they're able to better communicate to their fellow engineers, both through code and documentation and other forms. And of course, they're able to better communicate with humans, which means they write better code, which means hopefully that they produce better products. So that's it. Thank you very much, everyone. I would love to take questions. So we've got about 10 minutes for questions and maybe some comments if they're comments that I can follow up on. So I'll hand this one out and I'll use the lectern. Thank you. Hello? Does it work? Yep.
Thank you. I just had a quick one, not a hugely experienced programmer, so I always use auto formatting, and if I try to sort of tab out formatting or anything, often Visual Studio will auto format it for me. Is there rules, or do you always turn off auto formatting, or does it still respect tabs and things like that to some extent?
I leave that switched on, and I meticulously tell it what to do, and I'm very careful when I copy paste code around because I have learned what Visual Studio will treat as a request to auto format. So I probably should try and turn the ones that I don't need off, but I leave them on. But it's personal taste, I think, that one. But yes, that's quite right.
Hey, so I was really interested in your idea of basing programming concepts in an awareness of the reality of a situation. And that I think I like that idea from the perspective of working on something like a renderer or a resource system. But when you're working closer to gameplay, there's sort of a pretense that all developers in the team have sort of agreed upon to work within, like a framework that is not quite based on reality, that I would be really interested to know what kinds of mental gymnastics do we have to go through to put ourselves in the worldview to see some kind of reality to work from within.
Okay, so I don't have a great answer to that, particularly because I tend to be an engineer who works on lower level systems. But the takeaway that I would have is if the thing that you're trying to understand is something that someone has invented, then you're sort of limited to what that person has, I guess, invented for you. And so I think that hopefully they have invented something that is good and useful for the sort of things that you do. And I think that it is incumbent upon the person who's made that interface that the gameplay systems people are working to, it's incumbent on them to understand what your needs. So that's sort of a very tightly coupled communication problem, essentially. So hopefully that is a good enough answer for your question.
So sort of you would accept it as part of the domain knowledge and work towards that as being how you target the structure of your work?
I can't say that I have a great answer to that other than, it's the people producing the interface at the lower engineering level need to understand what your needs are and they need to communicate with you. If you are a gameplay developer, then the sort of things that you're going to be understanding from reality are certainly the needs of players and what will serve them best. And so you need to then obviously communicate that back to anyone who is producing systems for you so that they understand what those needs are and you can all work together. So there's not a nice answer to that, I think. It sort of comes down to your specific situation there. But yes.
Thank you.
I guess the right way to say it is please don't make gameplay systems code in a vacuum and just throw it over the wall, because that will result in not very good code that doesn't do the kind of things that you want. It will fail that test against reality.
Hey, mate. I totally share the sentiment that, engineers that can see the forest for the trees and kind of move up the awareness stack tend to be, better. But I wonder, I often see that leadership owns the responsibility to provide the context to make that possible, especially for more junior engineers. My question is, how much responsibility lies on the individual to grow that sort of ability? And anecdotally, how do you think that's cultivated in engineers earlier on in their career?
So I think that the important thing about the awareness stack is it is awareness. It's not so much responsibility for any of those particular areas. So it helps you make those small decisions. For more junior developers, it is incumbent on both the developer and their manager or their mentor to help them develop the awareness of certainly the particular business needs, but also if they're a junior developer, there might be some technical things as well that they need to develop. And so I suppose that's a way of saying, learning and development is actually really important. I've just given the broad strokes here, and you need to figure out what the exact details are for your situation. And it's critical that you have a manager that is involved in that process with more junior engineers to develop that for them. if you just leave it to the junior engineer, I think they're going to struggle a bit. Treat your junior engineers well.
Totally. We've got time for one more.
You mentioned early on code reviews and that you would like read through the code review like 3 times sort of thing. How do you, like that can be quite time consuming, I find. How do you go about managing the time you're spending time code reviews versus getting other work done, essentially, like getting actual code of your own written? I find code reviews can take up a lot of your time.
This is true. Time management is vitally important. It's something that I would have liked to touch on today, but time constraints. Thanks. I just realized that one. So, first of all, you're right. Code reviews can take up a lot of time. One of the things that I find in particular is code reviews can be an interruption. If someone sends you depends how you do it, but a message is like, hey, could you please review that? Try and make sure that your iteration times are, generally speaking, long enough that you can schedule when you do code reviews so they don't interrupt the flow of your own work. That's probably the number one thing in terms of time management around code reviews. The actual amount of time that you spend on code reviews, I think one of the biggest problems might be if you are the sort of person, again, who wants to spend a lot of time on readability and the rest of your team doesn't, and then they're writing a lot of code where you're writing a bunch of comments on the code review. It's like, hey, this is not readable. Hey, you could do this better here. Hey, you could do this better there. You're essentially then doing their work for them if they haven't put that thought in. And so there is a question of, it's a subtler question of, can you develop the culture around writing readable code that people have put a lot of thought into the readability of that code? Probably because if you try and go it alone to a level that your team is not at, you'll find yourself, I guess, fighting against your team, and that can take a lot of time in code reviews. If you have a code review and it's like, man, I read this and this is so readable, this is great, that's a really quick code review. And that speaks to the things I was saying about, hey, do you have a really rigid coding standard because your team is a bit messy, or is your team really diligent and you can loosen up a bit? So that's sort of one of the things that I want people to take away from this talk is this is, 3 big ideas. They're the broad strokes ideas. And I've sort of riffed on ways you can expand out from those ideas, but how you expand them out will depend on your team and your environment. So please take these ideas back and think about how you can now apply them to your own reality and your own situation and your own temperament and your own sort of personal philosophy. So thank you very much, everyone.